Hello. In past videos, I have talked about Ed Winfield, the grandfather of custom cams, performance cams. You know, the man that came up with three-quarter race that we laugh about today. But another person that I was very fond of when I was younger was Offenhauser. And I was fascinated by the different intakes and the names. I mean, you had Portasonic and Turbosonic. You had these really wild-looking intakes. You had multiple carburetors, and it was just really interesting stuff, especially because I was young. I was just getting started in some of this, and I really liked it. I've always had a catalog. Even when I did Speed Shop in the 90s and talked to people, Offenhauser came up. They had intakes for engines that other people did not. There was also some testing done in the magazines in the 90s. And I don't think a lot of people truly understood what Offenhauser did. And there's been a bit of a resurgence. They're starting to make stuff again. Somebody has picked up the plant. They have the molds. And so I thought I might talk a little bit about Offenhauser and some of its intakes. And the bottom line of all this is Offenhauser understood airspeed. And airspeed is an important thing. We don't talk about it a lot, though some people say I talk about it too much. But it's very important in how you get a motor to run. Now, he did some fascinating things, and let me see if I can actually get this to show up in the video. But one of the things is this split intake with an upper and lower. And there was lots of testings done on this particular intake, even back in the 90s, like I said, when I was working at the Speed Shop. And they didn't always go well. But part of that is because he understood airspeed, and we don't tend to. And so the testing was actually inaccurate. So basically, this dual split intake, which he calls the dual 360 intake, has a separation in the runner itself, with the primary side feeding a smaller runner and the secondary side feeding a slightly larger runner, and of course the two combined are the full size of the runner. Now, most of the testing I've ever seen was done by dyno testing. Wide open throttle on a dyno. Well, that's not going to show anything. You have primary and secondary completely open on the dyno, and so it just becomes a runner with a split down the middle. That's not the point of this. And that's why I want to talk about it, is I don't think people quite understood. Now, I saw a recent test where a guy tried to test one of these intakes against another intake using idle, using a fast idle going up a hill. And that's not really accurate either. Because if you're working on the primary side only, you will only be on this part of the runner. But if you're at a fast idle, the throttle blade is just barely cracked. You're not really moving any air. And the purpose of this is to increase airspeed. Now, if we start talking about a dyno and what you will see on a dyno with a given motor, you have a basic curve. You know, you have torque coming in, which I'm not worried about. We're talking about horsepower at the moment. And some of this is based on airspeed. When you hit peaks, when you hit peak torque, especially, because that's your highest volumetric efficiency, that's your highest airspeed. And then it keeps carrying until the air actually stalls, and that's your highest peak horsepower. And then you're done. So the engine is very much airspeed controlled, and it's something to think about. But what he's doing here is trying to extend this out in part throttle. If you run a big cam, a big carburetor, and an intake, you wind up with a soggy bottom end. It doesn't cruise well, it doesn't necessarily drive well, and part of that is because with a big runner as a whole, your airspeed drops and your fill at low RPM is not very good. And so what you want to do is try and drive up that airspeed. And Fred Offenhauser understood that. And maybe Ollie did too. Ollie Morris worked there and designed another thing called dial-a-speed or dial-a-flow. And that was to change the rate at which air comes out of the carburetor to increase airspeed. And they did dyno tests where they picked up low end and lost top end. Well, that's because as you increase airspeed, you will normally gain down here and lose up here because you stall sooner. Well, he's trying to do the best of both worlds. The primary is on a smaller runner. So when you are just running on the primary part of the carburetor, you are on a smaller runner and you are increasing the airspeed going through the intake so that your cruise is better. And this is probably the place where it's going to show up the best, your 2000 RPM cruise. Now, the other mistake people make when they test this is they assume low RPM. Well, if you automatically bring everything down, smaller cam, smaller carb, you're driving up the airspeed and you are basically missing the point. The point was to let you have a larger cam, a larger carb, and yet still have the best of both worlds. So when you're cruising along, you still have enough airspeed that it drives really nice. Now, you may have to fuss with the linkage on the carb a little bit to make sure at cruise you are staying on the primary, because you don't want to activate the second half of the intake, because then your airspeed starts to drop. Now, you can get a funny transition depending on how you drive when you're going from primary to secondary side, because the air in the secondary side is somewhat dead and it has to get going. And that could make a funny hesitation. I have seen that in the past. But the basic idea is just to increase airspeed at cruise, and that makes it more drivable. Idle doesn't move enough air, and if you're at wide open throttle, you're using the whole port. There's no point. So, like I said, a lot of the testing, even back in the 90s, I think, was just not properly done because they didn't understand what he was trying to gain with this increase in airspeed. Now, I know you're probably saying, well, some of that's outdated. Well, first off, airspeed is never outdated. We still need to pay attention to airspeed today. But like I said, I was fascinated by a lot of the different stuff he did. And of course, there was multiple intakes for multiple engines, some of which, like I said, you couldn't get another intake, but he made one. Plus, I really like multiple carburetors. I did as a kid. It looked cool. It seemed really something that made a motor. And so I learned a lot of stuff from the book. And as I got older, I learned that airspeed is important. So this is the 360 intake. And you see it's different from a dual plane. It's an open plenum and it's split down the middle. And I know what you're going to say. You're going to say, well, that has unequal distribution. And you are correct. Modern dual planes will probably outperform that intake because the firing order and how you cycle from cylinder to cylinder is certainly important, and this doesn't quite do that. But part of his goal with that intake was to allow different types of carburation. He offered that intake with dual quadrajet. He offered it with dual Holley. He offered it with six-pack. And so in his casting, that allowed him to generate different intakes with two-piece molds where he just used a different top on a bottom and made it work without having to completely design a whole new mold. So some of it was business-oriented. Now, you say, well, okay, that's great, but it's not right. Well, even when things aren't right, we can learn from them, and sometimes we can use it to our advantage. One of the intakes that came up in my world in the 90s, so we're talking decades ago, was an intake made by Potter for the Cadillac 500. And it was a open plenum design with a interchangeable top. And so you could take the top and change what you wanted to do in the carburetor. They're different tops. Some were cast. This one is just a prototype I made out of phenolic to try out 3/4 barrels. Certainly you could do other intakes, other carburation, dual quadrajets. So the problem is, in the 90s, when I first saw the intake, it was a big open plenum and a very short runner. And basically, this is a modified version, but it had an inch taller plenum up here, and it didn't have a divider. And guys had a terrible time getting it to run. And if you understand, short runners lower the airspeed. You need more RPM to get airspeed, because remember, RPM and airspeed are tied together. So you would require a great deal of RPM with a shorter runner in order to hit that peak airspeed. And the reason you need the peak airspeed is not only that's where the power is going to peak, but to get the cylinder fill with what you're doing. That's why I said even with this, you really want a bigger cam, because that takes better advantage of this. You don't want to use, a little 212 cam, because it's almost pointless to have that. You can just reduce the runner, you're already going to make less power, and you can run it that way because you'll have the airspeed. What you want is a motor that tends not to have airspeed down here, and you need to generate it. Well, this intake was the same way. And the problem is, a 500 Cadillac is a big motor, heads tend to have limited airflow, and it really tends to be a low RPM motor. So you've got a low RPM motor down here with an intake that has a big plenum and short runners. And it just didn't work out well. And over the decades, guys tried various things. They tried extending the runners out a little bit. One that I saw looked really promising. It was very nicely done. But then a tornado came in and demolished the engine and the car, and it never got tested, unfortunately. But we kept going on years and years, and when I first saw the intake, and maybe you've already said the same thing, well, it's a blower intake. Well, it wasn't meant for that. Potter had designed it for multiple carburetors. That's why he made cast tops that fit on it with different carburetor configurations. And so we needed it to work that way. Now, as time went on, Potter Automotive went out of business. Courtney, which is Cadco, bought the rights to everything they had, including the molds, and started making the intake. Now, for the most part, he was just using it as a blower intake. He manufactured the intake, they'd get sent to BDS, they'd make a kit, you'd buy a complete ready-to-go blower system that would bolt on a Cadillac 500. And that worked real well. But he came to me and said, I would really like to figure out how to make this work the way it was originally intended for carburation. And I had some ideas. And I'm telling you, they're not my ideas. They were Offenhauser's idea. And so, being a fan of that and looking at that catalog for so long since I was a kid, I knew one of the intakes was that split intake. And so that's exactly what we did for the intake. Now, we tried some other things. We tried some fillers. Even Richard Potter, back with this intake, used to putty them up and carve an intake out of it, which I didn't think was a great idea. But I decided to try Offenhauser's trick because he understood airspeed, and that's what the problem is. Now, like I said, remember, this intake was about an inch taller. I machined it down in order to reduce the plenum size. And then this divider reduces the plenum because even though it's split incorrectly according to like a standard dual plane these days, it will still increase the signal at the carb because each draw, one runner does a draw, it only sees this much plenum and not the whole thing. And that increases the airspeed through the carburetor, which is actually what draw is. And so that was going to get the air started a little faster, so it makes it appear to the engine that this runner is actually longer than it is. Now, you may be correct in that this does have a slight fuel distribution problem. It is way better with multiple carburetors where fuel is coming in at both ends. With a center carburetor, you have trouble because the center two run rich and the outside two run lean. And so it doesn't really work that way. And a standard dual plane would certainly work. Well, we have the Edelbrock for that, but this gives us the ability to do multiple carburetors without as much of a problem. Now you're probably asking, well, did that actually work? And the answer is yes, amazingly well. I have videos on this YouTube channel of dual quadrajets, I think dual Edelbrocks, and I think even the 12-pack is there on some separate things when we did this testing a few years ago. And I actually was able to make more torque than an Edelbrock intake with a single carburetor on it on the same motor. So we really find out that airspeed is really the governing factor of getting that fill. And Offenhauser understood that. And so you really can start working on using that information to make things function better. So we have gone from an intake that was really only good for a supercharger to an intake that can now run, you know, three Edelbrock 500s or two Edelbrock 500s or a couple of quadrajets or a couple of Hollies, you know, maybe even in line, though that's pushing the spacing a bit. You could put multiple Webers on. I mean, it's an open side. I could run, you know, 5 Weber carburetors on it and really throw somebody off because it'd have 10 stacks up instead of 8. But it gives you some flexibility for an intake that not only runs decent, but is also cool looking. And you can have something for a street rod that works and looks cool at the same time. And all of that was due to me understanding Offenhauser over the years to the point where I started understanding what he was about airspeed. And that's part of the reason I liked some of this stuff is if you look, I'm sorry, one page back, he had stuff like Portasonic, okay, and Supersonic. And if you want to look at a catalog, you can probably find one online as a PDF. But the names were cool. You had turbo thrust, tunnel ram, but all of these were utilizing airspeed. The basic idea is even if you're not dividing it, you want the runner to be sized correctly to give you airspeed in the power band you are trying to generate. Now, most of what Offenhauser was doing was kind of street strip. It was, we wanted to run really well, but not lose a lot of the drivability. So some of the intakes are single plane, but smaller runners. And I have done that in the past with some intakes for the Cadillac, where I ran something that was technically too small of a runner, but it was a single plane. And it actually ran very well for driving on the street because the airspeed stayed up, the fill was still decent, and yes, you were limited by total airflow, but what total airflow gives you is a curve where your peak is up here. Now, if you're okay with gear and converter and whatnot, that's fine. But a lot of times, we need to really pay attention to where that airspeed is happening. And it's a very hard thing for us to judge. Sometimes you really got to dyno test it in order to see. Or in the case of this, you might have to go driving a cruise RPM, or maybe today's hub dyno might be able to actually show that, because you could load it at a constant RPM, a constant speed, and actually measure what kind of power. So you could do maybe back to back and show that this generates more power at cruise. I'm not real sure. Somebody would have to look into that. But it just goes to show you that a lot of the stuff they were doing is all governed by manipulating the airspeed to get the engine performance you want. And like I said, we can't see how fast it's actually going. We can judge it by RPM. If we get done too early, then maybe our airspeed is a little too high, in which case we need to lower it. If we're having trouble down here, maybe we need to figure out something, a different intake or something, in order to control that airspeed. And like I said, I have done that. This is a very small runner for a Cadillac. Now, I ran this for years. This was very enjoyable, street driven on a Cadillac 500, and I converted it from throttle body to carbureted, and it did very well. And most people were surprised because it is technically a small intake, and they wouldn't do that. We tend to think of runners as, well, it's big enough to support the port, and that's really not what we should be looking at. And that's certainly not what Offenhauser looked at. We need to look at the intake being a main contributor of how fast the airspeed is. And like I said, I learned this from Offenhauser. So it's worth looking at what he did, trying to understand some of the stuff, and seeing a bigger picture about how the engine works, rather than it all being just right here at the port. We're fond of talking about airspeed and cross-section and everything at the port. But this is a whole system, and we need to look at the whole system. And Offenhauser understood enough to try and manipulate this to get some behavior out of motors that the rest of us are not. And we have not pursued that over the years, which I find to be a bit of a shame. But anyway, that's just a quick video about Offenhauser and Airspeed, and I wish you luck with all your projects, and I hope you do well, and I'll talk to you later.